Hi and welcome back to the product design course. My name is Bhumika Indu. I'm a mechanical design engineer with 5 years of combined experience in automotive design and marketing. I have worked for various top-notch projects like Volvo, Jaguar and Land Rover, Tata Motors and NIO. In this video, you will learn how to implement the product concept and understand how each of the steps have to be achieved. For this part, let us take the example of a lunchbox, a very simple looking product that everyone needs but every person has different expectation from it depending upon individual food habits. Let us assume that after going through phase 1, we have decided that this lunchbox should be suitable for office going people who need their food to be hot for a prolonged period. The main function of the tiffin is to hold the food and keep it hot. After talking to the customers who derived that they want a utensil that also prevents the food from spilling in their bag. The other attributes of the product are that it should be easy to clean, made of anti-corrosive material, lightweight, easy to carry. You have gone through different types of competitor products in the market to know that the existing alternatives and their limitations. The different kinds of boxes in the market are steel tiffin, which does not keep the food hot, gets corroded after a few years. Plastic tiffins, where food gets spilled and are also not very durable. Thermal box that have limited quantity of food. Again, Tupperware has the same problems. Steel box with rubber lid placed in jute bag, which are a bit difficult to carry. Bento box where food may get mixed up. Glass lunch box, which are again very difficult to handle, especially with children around. Going through the second phase, the lunchbox will be designed with different sizes and colors, keeping in mind the different ages and genders of the end users. You have decided to make an airtight insulated lunch boxes placed inside an outer cover with a handle. This box will have different sizes of boxes. Big one for rice or chapati, mid-sized one for curry or dal, and smaller size one for dry items or sweets. And the larger one will also have a small plate for salad. You have designed this with the Indian market in mind and hence it is more relatable to the Indian lunch pattern. There are different concepts that can be used to create these lunch boxes depending upon the material of the box. For example, for the boxes, you have microwavable glass, durable metal, leak-proof plastic boxes, insulated metal box with rubber insulation, right? For the lid, you have stretchable rubber, hard plastic top with airtight seals, and threaded metal lids. For the outer covering, you can have cloth bags like the jute, metal containers, or plastic containers. And again, for the handle design, it can be done in various different types. So, after the second phase, you are supposed to have a single concept in hand. Now, coming to the first step of implementation of the concept, that is embodiment engineering or embodiment design. In the embodiment design, we provide form to the selected concept. When a single concept has been selected or a family of products have been selected, all of which will go to the market together, embodiment design is easier. However, when a single concept could not be shortlisted and two or more alternatives need further investigation, they need to be developed in parallel until a decision is made. The sooner this decision emerges, the more the resources are directed at one single product, hence saving a lot of resources. Concept embodiment is the task that is most identified with an engineer in the product development process. Engineer must clearly understand the function of the product and its interfaces with the environment. Engineers are supposed to choose standards and specifications, component interfaces, materials, geometry, surface finish, fasteners and connectors, manufacturing processes, assembly processes. Let us continue with the lunchbox design. Suppose you have selected the metal box with rubber lids and plastic outer cover with a plastic handle. You can go to the Bureau of Indian Standard website and download the various Indian standards for utensils and cookware. Component interface here would mean how the lids and the boxes will be attached to each other, the fits and tolerances. If you are using stainless steel, it has certain specifications for the surface finish for food grade utensils. Utensils usually have rivets and screws for attaching different parts together. Each material and component will have a different way of manufacturing. Due to the limited scope of this course, we will learn about manufacturing in our modern manufacturing course. After this, you need to work on the assembly of these parts and the fasteners. This step needs to be noted properly as it is going to help you create the service manual later. Product models can be differentiated in two categories. The first category is depending upon the nature of the model. It can be analytical or a physical product, and the second category is depending upon the extent of problem solving. It can be a focused model or a comprehensive one. Analytical models are virtual prototypes which can be tested through computer simulation and modified through optimization, whereas physical products are hardware having real material and physical property correlation. They can be used for prototyping of manufacturing techniques as well. Physical models can range from experimental setups to fully functional mockups. Focus models are built for testing limited performance. They are just representative enough to answer the specific questions and as cheap as possible, whereas comprehensive models are full scale, fully functional dimensional versions of the product. They are as representative as possible and as true to real product as possible. In general, it is smart to make detailed engineering models when prototyping is expensive and when we have reasonable expectations in obtaining an accurate model. Always limit the activity to the available resources in time and money. The idea is about the predicted model accuracy over the entire development process. Making a more detailed engineering model may not always produce better results. Completing many experiments may also not always produce better results. To decide whether you should model or directly create a prototype, we will create a 3 by 3 matrix plotting the four parameters: model expense, prototype expense, model accuracy, and prototype accuracy. When model accuracy is high and model expenses are affordable, it is wise to create a model first. If model accuracy is somewhat average but expenses are low, you can still create one and test the model for most of the functions. Similarly, if prototype is affordable, it is a smart decision to create a prototype to validate your idea. The real ambiguity starts when a clear picture does not emerge. These are the cases where a engineer's decision becomes very crucial. In a case where prototype accuracy is very low while model expenses are high, you should go for a focused model which is specific to the problems that you want to solve instead of going for a fully functional comprehensive model. In the case where model accuracy is low but prototype building is very expensive, you can build prototypes using cheaper materials which can perform specific functions. During a go-kart design competition in college days, we used a plyboard as the floor and a scrap tin that we found in the workshop as the front structure of the cart. Only when we had the desired output from the steering and driving systems, we went to design the final outer body. This saved a lot of time and resources. In case when neither model or prototype can result in the desired accuracy and each incurs significant expenses, it doesn't matter whether you create a model or not. It is useless to proceed with such a step. Instead, you should go back to the second phase of design and look at the alternative concepts that might have better feasibility. Design for excellence. When you are given a task for designing a new product or redesigning an existing product, it is important to keep in mind the three main goals: cost, quality, and speed. These goals can be further split into more quantitative criteria which are relevant throughout the product's life cycle. The methodology of design that meets an all encompassing range of criteria is known as designing for X, where X stands for manufacturing, assembly, reliability, maintainability, serviceability, environment, life cycle cost. For each of these specializations, there are guidelines that help the designer to make the right choices among the alternatives. There are guidelines for how the best product structure should be made, how the correct material should be selected, labeling and finishing guidelines, fastening guidelines, and various procedures on how to check the environmental effects during manufacturing, disposal, and recycling of your product. You will find these guidelines along with the reasons why you should follow them in your Upschool portal. After all this, it is very important to check whether the final outcome is a robust design. Robustness is the minimization of variability in performance of the product under all expected environment and user conditions. It provides a basis for understanding the impact of noise on a product's performance. Clarity, where all functions should be unambiguously specified in form, parameters, manufacturing, and assembly. Simplicity, that is, minimization of information content within the product design. And safety, that is, minimal risks are created by the use of a product and ensuring that product has the desired strength, reliability, environment impact, ergonomics, and accidental prevention measures. There is detailed checklist of product design which helps you evaluate whether your design is a robust one. We have also provided this checklist in your portal. If you still have not enrolled into the course, please find the link in the description box and quickly get enrolled to get access to the checklists and design case studies and of course certification. In the next video, we will discuss what happens after the three phases of design. Thanks for watching.